Alright, let's continue with our list. Longest common prefix. Oh, it's a little slow because I'm on VPN. Alright, so this is easy. Let's hope that we can solve within 20 minutes. Let's see. Write a function to find the longest common prefix string amongst an array of strings. Okay, so we have an array of strings, so a bunch of words, and we want to find the longest common prefix string. Okay. Only lowercase English letters. So we have a list of words, and we want to look at the first letters of every word. So we have this common letter F, and now we look at the second letter, that's L, so that's still common. Then we have O, O, I, so that's no longer a common prefix, so we just return F, L. Longest common prefix string. Okay, so that's our algorithm. We wanna look at the first letter of each of the words in this input array, input list in Python, and then we check if they are the same letter. If they are, then we continue to the next until they are no longer the same letter, and then we just stop and return the first half of it. Okay, so we have this list called strings. We want to check all the words at the same time. So result is an empty string to start with. Can we check for all the words in strings? Let's use I as index. So for all the words in strings, okay, I guess we have to, okay, for I in range, let's look at the first word. So first word, flower, has 6 letters, so the length would be 6. So it can at most have 6 letters in this longest common prefix string. So what if we do for I in range of the length of the first letter, and the inside we will need to check if all the words in this list have the same letter. Okay, the letter we want to check is I, and for all the words in this list, if it's not the same as this letter, then we want to break. Okay, if it's not the same, then we want to basically return. Then we can just return result. If it is the same, okay, so we start from first letter F. So I0 letter is F. For all the 3 words, we want to check if word 0, the first letter, if it's F. Well, we can skip checking the first one because we are using the first word as this checking reference. So if they all have F, then we can move on to the next index. If it's not, then we are done and we return the result. So if we are able to get same letter in every word, then we move on to the next round. I is not 1, we have L, 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 so that's good again. But we need to store this in the result. So after we check all the words, we want to store this in the result. Put this letter in the result. And what if we had okay, let's say we don't have this flight here. We only have flower and flow. So after we have checked all the flow letters, what next round we have? E. And that is already out of index for the second word. So that will create an error. So that's when so when we are checking the word, if I is now equal to the length of the word. So if we are here, so I is 4, the length of flow is 4. If I is equal to that, then we already know that's it, that's the end of it. Or if that word is not the same. Okay, so that should fix that. Oh, I'm missing the first letter. Okay. Oh, this is... Okay, so this is incorrect. We do need to check all of the words, but what I really wanted is that we don't actually have to compare the first word with itself, but I guess that's fine. That's fine. Okay. Oh, good. Okay, it's efficient, it's correct. And I have apparently solved this in February this year. So no follow-up questions. Okay, let's do time and space analysis. So what are we doing? We are using the first word in the list as this reference word, and we have a for loop, and for each round we are checking if the letter for that index, we're using that letter. We check every word in the input list to see if they all have the same letter. So what is the time complexity here? So for word in string, so for each word, what do we have here? For all the words in this input, we are checking we are comparing just if that specific index has the same letter as the reference word. So we are not actually going over all the letters in this little for loop. We are just checking that one letter. So that would be checked as many times as the number of words in this. And then we are doing this for at most as many times as the length of the first word. So this part has time complexity of the number of words in this input, and this part has at most length of this, which means that the time complexity for this part would be at most the length of the first word times the number of words. So this will be a linear time complexity with respect to the number of letters in this input. So not the number of words, but the total number of letters in this entire list of words or array of strings. So that is linear time, and we have constant. Well, the output length. So we have at most 200 words, and each word is at most 200 letters. So that is constant space. It will be at most 200. Okay, so linear time, constant space. Let's have a look at other solutions. Okay, apparently they're doing sorting, which takes a log n. I don't think sorting is necessary. Oh, it's the cute cat again. Why do we need sorting? And what is the n here? Okay, so if n is the number of letters in this entire input, then that's not as efficient as linear. But if this n is like sorting as in, okay, let's see what they're sorting. So it's sorting the array, so that will sort it as, is it alphabetically sorted? Okay, it is in alphabetical order. Okay, so this algorithm This is pretty unique. I've never thought about this approach. So first it's sorted alphabetically, then it only compares the first and the last one because in between it's all sorted with these letters. So the first and last one will be the most different. And then we don't need to check whatever that's in between. That is very smart, but since we are sorting it, it's not gonna be linear time, so is this gonna be linear time? This is also sorting. Wait, is my solution not linear for some reason? Why are all the top solutions using sorting? Well, as I understand this, I is at most gonna be the length of the first word. And then what we're doing here, we're just checking each word at that specific index. We're not really going over each word inside this little loop. We're just doing this one constant operation, and then we do it as many times as there are words in this input list. So I do believe this is linear. I'm so surprised that no one has considered this solution. Okay, we have something else here. Shortest is the minimum. Key is length. Oh, is that's gonna return the minimum? I suppose this is a linear operation if we just wanna return the... Yeah, we just need to go over all the elements in the input and just look at their length and just return the minimum, the shortest one. Okay, so that's linear there. And then for I and character in enumerate, and shortest means that shortest word. For other in strings, okay, so the other words, we just want to compare. So this is more like what I'm doing. Yes, so this is what I'm doing, just a little different implementation. All right, so this is a linear solution. This is exactly like what I'm doing. Okay. And I also need to learn more about how to use enumerate in Python. Okay, all right, so that's it for this video. If you have any questions whatsoever, feel free to leave a comment, or if you have any specific LeetCode problem that you would like to see me doing it live, also let me know. All right, see you next time.